Hello and welcome to this webinar organized by the project Mainstreaming Innovation here at Glasgow Caledonian University. My name is Branka Dimitrijevic and I direct this project. This is a joint project of 9 Scottish universities and it's funded by Scottish Government. Before we continue, just a few housekeeping points. If there are any interruptions such as fire alarm or online interruptions, please try to rejoin us later. You will also be able to watch this video recording of this webinar in a few days. You are very welcome to start asking questions anytime during the webinar by using chat facility. And the webinar will close around 2 o'clock. Before we start today's webinar, just a few words about our current project, Mainstreaming Innovation. As I said, it is a joint project of 9 Scottish universities and the focus is on integration of low-carbon infrastructures. This means really that we are supporting collaboration between these 9 universities and businesses in Scotland to identify and develop innovations that will connect different types of low-carbon infrastructures such as water or waste, low-carbon transport, energy generation from renewables, also look into technologies related to energy efficiency in buildings and use landscape and biodiversity not only as a resource but also as an instrument for mitigation of climate change. If you need research input for the applications that you might plan to prepare for European, UK or Scottish funding, please do contact me and I will connect you with researchers at these 9 universities. The proposal for our current project has been developed during our previous project, Kickstart Online, the outputs of which will be presented today. We invited also some of the authors of the book that we published at the end of the project, Roaf of Heriot University and David Moore of Robert Gordon University, to participate in today's webinar, but unfortunately they were not able to join us. However, Tim Sharpe of Macintosh School of Architecture of Glasgow School of Art is here with us today. Welcome, Tim.
Good morning. Thank you for having me.
Before we start today's webinar, I will just say a few introductory comments about our webinar and our project, Kickstart Online project. When we planned the project in 2008 and then started in 2009, the target was really to collaborate with up to 20 different businesses to test innovations related to sustainable building design and refurbishment. However, during the first year of the project, we realized that we will reach that target within a year. So we raised the target to 60 collaborations, and finally we completed 71 studies related to sustainable building design and refurbishment. Although the book about the project was not planned at the start, when we saw the number of studies that were produced, we thought that it would be really useful to prepare an overview to provide identify clusters of different types of innovations that were developed during the project. So this webinar will provide an insight into the book contents through interviews filmed with the authors of the book chapters. After the interviews with 2 or 3 authors, we will have a break of a few minutes for comments to answer your questions. Then we will continue again with filmed interviews and so on. So you are welcome to ask questions by using chat facility anytime during this presentation. I will start off with just a brief overview of the whole project, Kickstart Online project. So it lasted between 1st of September 2009 and ended on 28 February 2013, and the focus was on innovations for sustainable building design and refurbishment. It was funded by Scottish Government and European Regional Development Fund and also Scottish Funding Council. And on the left side you see the 7 universities that were involved in this project, and the project was led by Glasgow Caledonian University. We received 90 applications for different studies, and 71 were completed. During the project, we worked with an independent assessment panel who looked into the applications, and they were representing Building Standards Division of the Directorate for the Built Environment of Scottish Government and Scottish Enterprise, Scottish Association of Building Standards Managers, and Energy Efficiency Consultants. So only when they were satisfied that these innovations would benefit Scottish SMEs, the applications were approved. These applications or requests for assistance were driven by the industry, and they really indicated the areas in which the industry needed assistance. And in total, 51 academics worked on these studies. Beneficiaries were different types of organizations. It was interesting to see that the largest group were architects. So we had 23 architectural firms collaborating. Then housing associations, manufacturers of technologies for renewables, software developers, building contractors, environmental consultants, then waste recycling, and so on. So a wide range of different types of companies which have different interests in development of sustainable building design and refurbishment. By the end, in March this year, I checked the numbers of how many members we had in our project. So as you see, it was over 2,400 members from over 1,600 organizations. But we also had over 200 international members from 53 countries, and the largest group was from USA. The project outputs, the outputs of feasibility studies were delivered through webinars. In total, 40 webinars were delivered, and the membership is free, so anyone can still join the project and watch these webinars free. We also had quarterly online magazine, and we published information about the best practice in sustainable building design and refurbishment, but also research and other news of interest in that area. We organized 2 online conferences. The first one was on sustainable refurbishment, and the second on the resilience of buildings and neighborhoods and cities. And for these conferences, we filmed, for the first one, 7, and for the second one, 8 videos, 1-hour-long videos on different topics of research undertaken at universities that were involved in our project. We also organized live conferences. For example, this one that was held in 2012 on building tight and ventilating right, which is about air quality in houses. And all live events were very well attended. In total, we had 15 live events. Most of them were filmed, and DVDs of these events are available. At the end, we also wanted to organize all these outputs in a way that can facilitate search for different topics that were addressed in our project. So on our website, you can find a knowledge base which has these 15 categories. And then when you click on each category, you will see different keywords related to that category. And then by clicking on keywords, a page would be open with either or all videos or recordings related to that topic, which show the outputs of different studies, or articles in our online magazine, or video recordings from conferences. So we hope that this really enables easy search for different outputs of our project. And finally, we decided that it would be very useful to publish a book that would provide an overview of different clusters of innovations that were developed through our project. And the titles of these chapters really reflect the different clusters of innovations that we identified within the project. So the book was published in November 2013, and it is also available as e-book. in each chapter, there are references to all the studies, all the project outputs, and also at the end of the book there is an overview of all the outputs with the links on the website. So the book is really there as an accompaniment of our website, so that if you read the book and you find something of interest, you can immediately go to the website, find the full report, all information in more detail. So that is the brief introduction, and we can now start with film interviews. First of all, first speakers are Richard Lang, who was interviewed in relation to his chapter towards a more sustainable built environment, and then we'll listen to Sue Roaf and Rohinton Emmanuel providing their comments regarding their chapter on planning for resilience. So let's see the first.
Okay, Richard, how do you
set
think
of
Europe
interviews.
is driving change in relation to sustainable cities?
Within the Kickstart project, it's been very important for us to recognise the role of Europe, because I think Europe has tried to work to make sure that all of the member states are kind of moving in the same direction in terms of sustainability generally, but specifically for this project in terms of the built environment. So it's been interesting for us in the project to then look at how policies and directives that are maybe coming out of Europe have filtered down within Scotland, and it's been possible for us to maybe demonstrate how some of these policies are having a really positive effect within Scotland itself.
And how do you think Kickstart helped support this?
Well, I think one of the important things about Kickstart was that it helped academics who were already interested, sometimes in a kind of theoretical way, about the ways in which the built environment might become more sustainable, to work with companies, often smaller companies, to try to help them demonstrate or test solutions that they might have. And I think that's been a real, and it will be a lasting contribution of the project as well.
And what are the challenges related to new and existing buildings?
I think this is one of the main challenges that's facing Europe as a whole, actually, in the sense that we quite often talk about kind of challenges facing us over the course of the next few years, up until 2020, for example. But we know within the built environment that most of the buildings that we'll be using in 2020 or 2025 have already been built. And a lot of those buildings were constructed before we really had stringent building controls about sustainability that we have now. So we have real challenges in terms of trying to retrofit older buildings or improve their energy performance and reduce the carbon emissions that are associated with those buildings. And that's slightly different to, I would say, with newer buildings, where we've got a different challenge, which is trying to make sure that anything we construct now is going to be as close to very low energy or zero energy use building as we can possibly get.
Right, thank you, Richard.
Thank you.
Hello, so I would like to ask you a few questions about the chapter on planning that you have written for our joint book. One of the topics you wrote about was about resilience of urban neighborhoods and cities. Could you tell us a bit more what is really important about the resilience of urban settlements?
Well, Branka, you know that around the world, increasingly, communities are beginning to get to breaking points. And we've seen that in the Arab Spring, in Istanbul, we've seen it in Sao Paulo, where the actual society, 4 million people got onto the street in a day because they put up one price, and that was the price of the bus ticket. It was a single bus ticket, the bus ticket that took them to work and brought them back. But that was sufficient, that no longer could the family afford their week's expenses on what they earn. And so they got out on the street, and increasingly, as we see energy prices rising and rising and rising, I think that society is going to get very brittle like that. And so I think planning has a major role and function in how we develop communities that in the future can be increasingly self-sustaining in terms of energy. Planners up to now have thought that their main aim in life is to keep the world as it was 50 years ago. But in fact, what they have to do is re-envision or reimagine a future as it's going to be in 50 years' time, an ideal future, and create energy systems through their planning laws and legislations that will keep people safe in their own homes. Because if a society or a community breaks, then what does it matter whether they've got planning laws or not?
In that context also, the context of resilience, how does climate change affect urban environments? For example, flooding. What we can do to strengthen the resilience of urban neighborhoods regarding climate change?
Well, what's brilliant about this book is that considering issues of planning and resilience in Scotland, it incorporates, as you know, so many of the other contributions of, I think it's 70-odd studies that have gone into the book, but each one has a part to play. But you always have to drill back to the fundamental question of why we're doing something. And the reason why we need to change our approach to planning radically is that climate change is really, the rate of change is happening faster and faster. The rain is more often, the rain is heavier, more and more houses are flooded. So we have to develop a planning system that doesn't put houses on the floodplain, that starts to build in managed retreat from that risk, starts to develop stronger houses. Because, I mean, in some of these studies, we've seen traditional Scottish homes that are getting increasingly flooded where they never flooded before. So all the studies on the construction as well as the planning are important. So we have the challenges. How do we protect people in their home through planning? And up until now, the key idea, for instance, I noticed in here, the key idea of the planners was that houses have to look like they did 50 years ago. But here we have these studies of tenement blocks where the planners in Edinburgh and Glasgow have prevented people from even getting double glazing. But studies show now that it doesn't actually make any difference to how they look, and yet it has a profound impact on the quality of life and the energy costs of people in those flats. So we need to radically rethink where our priorities are. And all you have to do is read the chapter.
You have done a lot of work, a lot of research on solar energy and its use as a renewable energy, and how it affects and reduces fuel poverty. Could you tell us more about your work and what you have contributed in that context within this book?
Well, as we go into a world with less and less fossil fuels, more and more expensive energy, increasingly individuals, and if you take, for instance, this ordinary middle-class house here, this house can get extremely low energy bills with good construction and sensible windows and glazing. But the only way you can take it from really low energy down to almost zero energy to future-proof the people in it is to make sure you generate your own energy on your own building. So here we've got photovoltaics, solar hot water. Now this is a middle-class aspirational house, and more people have begun to wake up and say, actually, I want to decouple myself from rising energy bills. I'm going to put solar on my home. But the tragedy is that the people who spend least on energy for heating and cooling their buildings already, for on electrics, is the fuel poor. And nearly, over 30% of people in Scotland are living in fuel poverty. So we have a social imperative to start to put free energy on people's roofs, free solar hot water onto the council housing, onto the social housing, because there is only one way to take the fuel poor out of fuel poverty, because they're already using as little energy as they can get by with, is to help them have the means to generate their own energy. So the studies we've done in Dundee, and if you look up Scotland solar cities, you'll see some of this work. The only way is to put solar energy on the homes of ordinary houses. That's what we've tried to put in this particular chapter. It's a really important message to get across, not only to designers and to planners, but also to policymakers in Scotland, because if we do not take people out of fuel poverty, we will increasingly have societies that break and we don't want that.
So thank you very much for this insight into the chapter about planning that you have written for our joint book. Thank you.
Thank you so much for allowing me to be part of this excellent book, Branka.
Thank you. Hello, Rohinton. You wrote about the problem of urban heat island in the chapter about planning in our joint book. Could you tell us, please, how Kickstart online project has helped in highlighting this problem?
It is typically felt that in Scotland overheating is not a problem. So, however, in the changing climate in 20-30 years, the current London climate will be Glasgow's climate, for example. So what way that Kickstart has helped is in the dissemination of work that is already happening in the Glasgow Caledonian University. So I think that in two ways it helps. One is the dissemination, the other is propagating the strategies that we're coming up with to tackle this problem, which may not be an immediate problem, but in some years to come, urbanization will make the problem even worse. So we are getting ready to with possible scenarios, strategies. So yes, Kickstart helped in the dissemination, I think. Yeah.
Could you tell us what strategies would work in tackling this climate change in Scotland?
There are usually three areas that are suggested to arrange buildings in a conducive way, to change the building materials or green infrastructure. But given our climate, the wet and relatively low sun climate, it is green infrastructure that is usually most profitable. So our work has focused on how we can improve the green infrastructure, by which I mean the greeneries, green trees, green roofs, green grass, everything that the ability to increase the greenery in the streets and urban areas.
Have similar attempts been made in other comparable climates?
Yes, one of the countries that is well known for these kind of efforts is Germany. They have attempted to put in their planning laws the green area ratio, because not all greenery is equal. Green trees are better than green roofs, for example, or green grass. So they have attempted to weight the green infrastructure, so which is now part of their planning law. So we mentioned that in the book as well, and how it could be adapted to Scottish or west of Scotland climate and urban growth. Yes.
Thank you very much, Rohinton, for highlighting these details from the chapter that you wrote.
Thank you. Thank you very much.
Well, we can now start with some questions and comments. So I would encourage our online viewers to ask questions by using chat facility. But let's start with some comments here, Tim. Regarding Richard Lane's chapter about planning and legislation, European, UK and Scottish legislation related to sustainable built environment, what would you say? Why is it important to know where legislation is going, where investment is going for everyone who is involved in building design, sustainable building design and refurbishment?
It's clearly important for anybody who's involved in the construction industry to be aware of what the legislation is, both in terms of how they're planning their work, but also as a way of informing those policy decisions. We are in territory now, because the legislation has moved on so quickly, that certain things are coming through very quickly and then are being implemented very quickly. So there's an opportunity there to learn from that as well, and to inform kind of future policy. So are the strategies we're putting in place through legislation working? So it kind of works in both ways. It's not just necessarily following this legislation, it's also trying to influence that in some degree as well. But clearly, knowing what upcoming legislation is going to be is important in terms of future planning, in terms of scoping out new strategies, new materials, new techniques, and trying to get those developed into construction.
Thank you. I would like also to say a few words about the chapter Planning for Resilience, because I also contributed to that chapter. I wanted to highlight in that chapter some conference videos and feasibility studies that contributed to better understanding of the relationship of planning and optimal use of low carbon technologies. One of these studies was a feasibility study about the development of a hybrid solar thermal mass system for the application in new housing. And this study was undertaken by Glasgow School of Art, Macintosh School of Architecture. The study proposed alterations to an existing master plan to enhance the system's performance, as well as some communal functions. And then key guidelines for the alternative design proposal were drawn after discussions with the representatives of the Housing Association. Another study also included a solar photovoltaic design guide for Scotland. This was produced by Professor Tariq Munir of Edinburgh Napier University. Adequate planning for optimal use of photovoltaics and thermal solar panels can also contribute to better performance of other low-carbon building services that are integrated with them, such as heat pumps, as was demonstrated in another study. So planning that takes into consideration conditions for optimal performance of low-carbon technologies can contribute to the reduction of fuel poverty. I would also like to highlight one video that we filmed for our second conference, video on energy cooperatives as a means of achieving sustainability within the housing sector. This video was filmed in collaboration with Edinburgh Napier University, and currently, I just checked recently, it has been viewed by over 4,900 viewers on YouTube. This is also a topic that is very much of interest now regarding community energy generation. So that is a video that is worthwhile checking on YouTube. Well, I suggest that we continue now with our filmed interviews, and the next one will be with John Brennan of the University of Edinburgh, who wrote about a chapter about building design, and then David Moore of Robert Gordon University, who wrote the chapters on technologies and construction. Hello, John. Your chapter in our joint book is about building design. What are the key features of sustainable building design of the projects that were presented through Kickstart Online?
I think one of the really interesting things about the Kickstart project is showing the way in which sustainable design, low carbon design is changing. And what we're seeing is two main strands. One strand which is quite technologically intensive, and another which seeks to find more straightforward and more robust ways in which sustainable design can be achieved. I think a good example of a complex solution would be that of the kind of general passive house technology, where we see buildings with very, very high performance specifications, very, very low energy use, allied with quite sophisticated means by which ventilation and air tightness is achieved. And certainly for certain clients, certain client groups, it's a very, very appropriate way to go forward. However, if we look at some housing associations feel that to achieve passive house standards means that the buildings often don't perform as planned because they're used in slightly different ways than was envisaged by the designer, or the buildings change and adapt over time in ways which means that, for instance, the air tightness layer is breached for whatever reason. So what we see now is we do see much more of a kind of robust attitude towards sustainability. So for instance, if we look at buildings such as a Carrickle Primary School, where you see very, very sophisticated ways in which the building is put together in terms of using low toxicity materials or use of Brecht Staple. We see very, very low carbon, very, very low impact building materials and building constructions, yet with a servicing strategy which is quite simple and quite straightforward. The interesting thing, I think, which is important to say about these more robust ways in which buildings are now designed, is that to predict their behaviour, sometimes the most sophisticated means is required through, for instance, environmental simulation programs, because, for instance, when one's looking at natural ventilation or the use of sun spaces, trying to predict the way in which that's going to work, as opposed to looking at more straightforward mechanical ventilation systems, means that the way in which you actually go about predicting behaviour is one where the simulation software one uses is quite sophisticated.
What would you say, how does a life cycle of buildings and their occupants affect building design?
I think if you look in a wider sense, I mean, life cycle costings, life cycle analysis is becoming so important in the built environment. And what we're seeing a lot of, there's a lot of work out there, for instance, in the way in which maintenance is dealt with over the life cycle of a building. And for instance, the specification decisions you make right now have quite profound effects later on down the line. The interesting thing now in a contemporary context is the fact that when one looks at sustainable building and sustainable design, looking at adaptability is really important. This is because whenever you change a building, it has an environmental impact. The less a building has to change over its life, the less environmental impact there is, the more sustainable it becomes. So if one looks at the way in which the building fabric changes, for instance, things like services, furniture, building skins, those change at quite a rate of knots, and therefore it is really, really important that we design those in such a way so they have as little impact as possible. While things such as the basic structure of a building, say for instance a concrete frame or a steel frame, because they're going to be there for 60 to 100 years, that becomes less important. The important thing is that buildings do change. Somebody once said that all buildings are predictions and all predictions are wrong. And the way in which we design buildings and design spaces within buildings so they can change becomes very, very important. There's this idea of soft adaptability, where, for instance, if you make spaces and rooms within buildings slightly larger than they need to be, simple in shape, generous in height, then you're always assured that they can be used for more uses than we can even contemplate right now.
What do you see as key challenges in sustainable building design of both domestic and non-domestic buildings?
I think there's a number of challenges. The first challenge is one of the regulatory climate. So following Sullivan report, the emphasis is always going to be on carbon reduction. And the difficulty often is that when it comes to regulation, there's a dictum of measure what you can manage and measure what you can measure. So for instance, that predicted carbon outputs, predicted energy outputs will always be ratcheted down. And as a result, we've pretty much, I think, got to the limits where the building fabric alone will provide users and designers with the energy efficiency that regulators now require. So I think that airtightness is going to be incredibly important. But we can't just make buildings airtight without dealing with the ramifications of that in terms of ensuring that we have healthy internal environments. So I think in the domestic front, that's going to be very, very important. In terms of non-domestic buildings, I think it's more nuanced. I think that the challenge is much more about ensuring that people who are commissioning and procuring buildings know that some of the decisions they make in terms of life cycle costings are going to become more and more important as energy price changes and it will be becoming more and more expensive. So buildings which are easier to maintain, buildings that are adaptable for change, buildings as well in a more selective labour market where people are happier working, all these are going to become very, very important.
Thank you very much.
Thank you.
David, I would like to ask you a few questions about the chapters on technology and construction that you have written for our joint publication. Scotland has shown itself to be willing to adopt a relatively demanding approach to arriving at a more sustainable built environment. Within this approach, there has been an emphasis on using both innovative and improved technologies to significantly improve the performance of new and existing buildings. However, such an approach is viewed by some as being of concern. New technologies and construction methods can be seen by some within the industry as uncertainties that they would rather avoid. How do you view the technology and construction chapters as helping to reduce such uncertainties?
I think the chapters come together in a way that helps to support good decision making by providing information that essentially construction SMEs can trust. It's been tested, it's the results of research using the real materials and methods, etc. And it's in the one location. So it saves them time in the sense that they don't have to research extensively to try and find information that is useful to them on the day-to-day basis, the kind of activities that they may be presently doing, but also possibly thinking of moving into doing. So with a new area, there's always that aspect of uncertainty, maybe a slight lack of confidence. So the two chapters bring together information that relates to things that people do on a day-to-day basis in terms of their traditional skills. We may be using new materials, but also perhaps moving into new areas. And that's one of those aspects where usually people kind of don't know what they don't know. So trying to find the information can be time consuming, it can be frustrating, you've got to use the right search terms, etc. There can also be an expense to it, in that journals are increasingly seeing a value in material, a financial value, that wasn't there previously. It was regarded generally as being too niche. However, now the area is expanding and more companies are becoming involved in this kind of work. It seemed to be valuable. So by putting this kind of information in a publication such as this one, it makes life easier for the SMEs, gives them some certainties with regard to the outcomes that can be achieved, and it also saves them time in searching for the information.
Would it be fair to say that the content of the book is written with a specific type of user in mind? Is it, for example, written for use primarily by architects?
Traditionally, targeting a specific users has been seen as quite an efficient way of doing things. It saves on marketing costs and all sorts of issues such as that. And in the construction sense, the traditional role of the architect has meant that they have typically been one of the main targets. However, for this particular publication, I don't think that's the case. I don't feel that it is the case that the target is specifically architects. Is to just look at the membership of the organisation behind the book, and you can see that there are a vast range of areas of expertise and skills that people bring to their day-to-day activities. So yes, architects are very interested in this kind of thing, but so are a lot of other expertise areas and skill bases. So we've got quite a wide range of people, and of course we could include also the enthusiastic DIYer, someone who's at home, wants to make some significant improvements in their property, as with recent television programs where householders have been encouraged to make relatively small changes, but they've been given the confidence through the information that those changes can actually work. So we don't have a situation here, I think, where it's just architects that are being targeted. Some of the technologies that are included, and some of the methods of construction that are included, are relevant to anybody who's interested in this kind of area. I mean, one of the pieces of work that are reported on in the chapters relates to bringing together two separate technologies, traditionally used separately, which are heat pumps and solar thermal collectors. Both of them have got their problems, but the theory would be that bringing them together in the right kind of way helps to overcome their individual problems. So it's the kind of thing that the enthusiastic DIY individual may very well be tempted to try at home, and could spend quite a lot of time, quite a lot of money on materials, etc., trying this out, and perhaps not get very good results at the end of that. By doing this work in a controlled manner, we can trust the results that come out of it. And in this case, the example that's been reported on, the results show that it's not such a good idea. The actual performance improvements were quite marginal by bringing these two previously separate technologies together. There were some improvements, but it was perhaps not as cost effective as we'd initially thought. So not just architects, anybody who's interested, who wants to try different ideas of this kind of area, there's a resource here which is useful for them.
In terms of sustainability within the built environment, it seems that the most of the discussion relates to either new technologies or ways of improving efficiency of existing technologies. However, is there any evidence of novel ways of building houses, for example, that relate to the construction process as a whole?
This is, again, the traditional construction environment as being one of the frustrations that certain parts of the supply chain have experienced, and the end users in some cases have experienced, in that they've maybe wanted to be quite innovative with regard to the materials and technologies that they've used, been able to use, but they've not been able to do it. Again, it's a matter of information, what works, what doesn't work. So within the two chapters that we've got here, we've got evidence about various things which do work, which allow people to be innovative, because traditionally there's a more cautious approach to these things where the temptation has been to build in a fairly traditional manner and then essentially bolt on technologies that have helped the situation, but by being that little bit more radical, but in a way which you can show that you've got evidence to show that it does actually work, then you can trust the results. And again, that should encourage people to become more innovative, to do more radical forms of construction, passive house, etc. All of which are increasing, but perhaps not as quickly as we need them to increase in order to meet certain targets. So wherever we've got some information which will help people make decisions that relate to how they go about doing the building process, that's all very useful. And the construction and technology chapters give examples with regard to that. One example being a piece of work which was carried out by a team from Strathclyde, who looked at a traditional Glasgow tenement building, a flat within that, and did some quite radical work. But the focus of that was not so much how much you would save on your fuel bills, but how much you would save in terms of levels of CO2, which for some people actually is the more important end point. So having, again, reliable figures about how much individual technologies, ways of constructing will save you in terms of CO2, that may actually be more useful to some people than knowing that a particular technology will save you £50 a year or whatever on your electricity bill. So the work by Strathclyde, it looked at a number of different technologies, things from replacing the boiler with a new boiler, through to insulation on the walls and applied in a particular kind of way. What was the CO2 savings from that? What was the cost of each of those? So which of those various approaches that were tried actually give you the best savings in terms of CO2 for the money that you spend? Now, in the particular example within the two chapters that we have, the particular example that was given, it was perhaps surprising that some of the technologies and methods which are presented as being great in terms of reducing costs were perhaps not so great in terms of reducing CO2. So a slight change perhaps to the strategy that will be adopted if your focus is on CO2 rather than reducing costs. So one of the most CO2 effective purchases was putting in a new boiler, and quite quite cheaply. But that was in this one specific context. So again, it's important to have the information that in what context did this particular technology give this particular result. And if your flat that you own as an individual fits with that, then again you can say, I could use this in my circumstances. If you're a larger developer, a small housing developer, who've got multiple units to produce, then it may be that you go for a slightly different solution. But again, the work that was carried out by Strathclyde and other universities involved in the project helps to give that certainty and guidance with regard to the outcomes that are achievable.
Thank you very much for this insight into the 2 chapters that you have written. Thank you.
Thank you.
Okay, we can now again continue with discussion, but I would like again to encourage our online viewers to ask some questions or give some comments in relation to the topics that we already spoke about. Maybe in relation to building design, the topic John Brennan was talking about, there is an interesting point that in both our previous project, Kickstart Online, and now in Mainstreaming Innovation, we have a quota of membership among architects. What do you think, Tim? How important is really collaboration between researchers and architects, or continuous professional development also for architects, for their positioning now in the construction sector?
I think that's very interesting. I also think it's very, very kind of positive that architects are so engaged in this process. The things that strike me is that sort of 20 years ago, an architect could manage their practice knowing a certain amount about building technology because it didn't change very often. These days, things are changing all the time, and they need to be up to speed with that. And what was sort of working one year is sort of has been superseded the next. So staying abreast of those challenges is quite difficult. Right, and so I think that's one of the reasons that architects are involved in these sorts of things. They're engaging with researchers to find out what's up and coming, what's going to be the next kind of best thing. I think the other thing which is very encouraging is that architects are involved in this. One of the dangers in this territory is that with more and more targets, you get more and more kind of specialists. And the danger there is that everything becomes incredibly fragmented, and you get one person who's dealing with the heating system, someone else is dealing with ventilation, someone else is doing a particular piece of technology. Yeah. The good thing about an architect's role is that they can take the holistic view. They can look at the whole building, how it's supposed to work, how these things can interact. And that's tremendously important. If we don't get that holistic view, then you can have some great technologies, but if they are competing with something else or not working terribly well, then the building as a whole won't perform.
Yes. And in relation to technology, how important is it to really have simple solutions for their use in everyday life?
Well, the thing about a piece of technology, particularly in buildings and particularly in housing, for example, is that the technology is only as good as the way that people use it. You can have the most super duper efficient heating system. If it's not turned on, it's not working. If people are using it incorrectly. And I use the word incorrectly, sort of inverted commas. I mean, often part of the problem that these things aren't particularly well designed to be used by people. And so they have controls which aren't very intuitive, or people haven't been told how the thing is supposed to work. So the design of the operation is equally as important as the technology which is inside the box.
Yes. Okay, we don't have any questions, so let's continue then with some filmed interviews on refurbishment. Paul Baker of Glasgow Caledonian University will talk about that, and then of course with a short interview with you, Tim, about building performance evaluation. Hello, Paul.
Hello, Branka.
I would like to ask you how Kickstart Online projects have challenged the assumption that traditional buildings in Scotland are hard to treat regarding energy efficiency.
Yes, I think the current perception is that it's the options for upgrading traditional buildings are very limited, particularly for solid wall buildings pre-1919, buildings particularly tenements, etc. in Scotland. But and it's obvious that restrictions do apply to, say, listed buildings where there are features that you know, you have to be very careful about what you do, and conservation is very important. But I think that recent work, that particularly for English heritage, historic Scotland, SPAB, has shown that often the actual thermal performance of the fabric of older buildings is certainly not as bad as people assume. For example, if you were doing an RD SAP assessment. And it's also questionable whether you should remove traditional windows when work has shown that there are relatively simple measures that can be used to improve their energy efficiency, including using quite high-tech slimline glazing, for example, which is becoming acceptable now. But I think with Kickstart, you know, various research projects were carried out, and these definitely challenged these assumptions. And I think that they showed that if you took a holistic approach, which balanced conservation needs and energy efficiency, and you know, considered the possible risks of refurbishment and the other impacts of building performance, then you can achieve quite a good solution.
What are the requirements for upgrading the housing stock, traditional housing stock in Scotland?
Yes, well, I think that Kickstart showed that we're gradually developing a better understanding of what the limitations and requirements are for refurbishment, particularly of solid wall traditional buildings. And I think there's 5 main points. There's achieving appropriate technical solutions, and you know, this could range from appropriate insulation to energy efficient boilers, for example. The second one is that you need to quantify what the energy saving measures and CO reductions actually are. And the third one, probably the most important one in some ways, is cost, obviously. The fourth one is conservation issues. And the fifth one, which I think is very important and can be overlooked, is risk to the fabric. So, you know, I think Kickstart in various projects showed that you could weigh up all these factors, and particularly with the aid of, say, simulation tools, you could arrive at a kind of good solution.
So are there general solutions or guidance that can be applied to the refurbishment of buildings in Scotland?
I think that we found there were common themes developing through the research, and particularly in the tenement case studies, where I think, you know, there's quite a large percentage of the housing stock certainly in the central belt of Scotland, that are tenements. But all that experience could go into devising a fairly general strategy for upgrading buildings. I think the 3 main points from that were looking at the assessment of the physical condition of the building. And you need to have a good starting point that you need to avoid problems from poor maintenance of the building, like leaking gutters. It's fairly obvious, but I'm not sure that it's always thought of. And then by a process of maybe using simulation and cost analysis to propose appropriate strategies, and then finally ranking solutions, almost coming up with a shopping list of different solutions based on the CO2 savings, for example, and the costing. And I think another issue that's important is actually trying to carry out post-refurbishment monitoring, and I think this is particularly important for looking at risk factors like moisture problems, which certainly there's a strong sort of conservation lobby that says, oh, if you insulate you'll get condensation problems, but we're still really at the beginning of that process. There are a number of projects being carried out, for example, Historic Scotland, which are looking at different refurbishment techniques, and hopefully at a couple of years' time I think there'll be enough information to give much firmer guidance.
Thank you very much, Paul, for these highlights from the chapter that you wrote for our joint book.
Thank you.
Tim, you wrote about building performance evaluation in our joint book. Tell us why building performance evaluation is important.
Building performance evaluation is a really important component in buildings these days. One of the things that we are not very good at is learning from the results of our experiments, and most new buildings these days are experiments. We're trying new materials, new construction techniques, new designs, and it's really important to go back and see if they work. Building performance evaluation is a means of doing that. It's a means of seeing if the thing actually works in practice, what works well, what doesn't work well in that building that you can fix, and then what doesn't work well that you can apply to other buildings. So in future designs you can do things better.
How is building performance evaluation undertaken?
There's a number of different tools that you can use for BPE. They range from the sort of scientific, the measuring, so measuring energy use, energy consumption, temperature, humidity, those kind of things. But there's lots of physical testing you can do, things like thermography, co-heating tests, air tightness tests, a number of different tools like that. But a really important component is actually speaking to people in the building, see how they actually use the building, how they occupy the spaces, how they interact with the controls and so on. The measurement tells you what, but the people tell you why, and you need both sides of that.
Yeah. So what we can learn after undertaking building performance evaluation?
There's lots you can learn. You can learn lots about that building in terms of is it doing what it's supposed to do? Is the design robust? Is it meeting that design performance? And frequently the case it isn't, and so what that then tells you is why it might not be doing that. It then enables you to learn how to apply those lessons in future designs, but also in future modelling as well, because we have to adapt these models a little bit to take into account kind of real life factors.
Thank you very much. Okay, well, we have the first question here for you, Tim. If you would like to read it from an online viewer.
Okay, so the question is how to implement a holistic approach to architecture when there is an increasingly prescriptive process to deliver sustainable buildings. Yeah, so it's a really good question. I mean, to which there are a number of components to the reply. I think one of the things which is really important is that architects need to be taking back some control over the design process, which probably means that they need to upskill to a certain degree, particularly in terms of technical issues and performance, so that once you get beyond planning stage, it then isn't all handed over to an MEE engineer or somebody like that, or a subcontractor or manufacturer. Which means architects having an overview of the building process, which may feel like a backward step to some, but it's not. I think it's the opposite, really. It's that architects would have some responsibility for the design right through the design, construction and occupancy process. And I think this is tremendously important. In order that the architects can then learn from that, they can learn a lot more about construction, they can learn a lot more about how buildings are actually used, and then they can use that in future design processes. I think the other thing is that in a sense, the cat is a little bit out the bag in terms of performance gaps, and legislation knows about this now. Building standards know about this. Government agencies know about this, and so the questions now arising are: what are we going to do about it? How do we deal with prescription legislation in order to try and resolve some of these problems? And again, so I think architects have a responsibility and and I have to say a big opportunity here. To be the one group of people who take that overview of a building and try and deliver it.
We'll see if any more questions will come, and I would encourage online viewers to ask them. But looking back now into a range of innovations that were developed through Kickstart Online, what do you think? Have they reached the market? Are there any barriers in the market for them yet still?
I think a lot of innovations have reached the market. I mean, it's interesting, a lot of innovations which are reaching UK markets actually have been in other markets for a long time. You think of things like heat pumps, for example, have been around in Europe for donkey's years. Very well tried and tested technologies. You speak to people about heat pumps and people say, well, I'm not sure, I haven't heard about it. Everybody's got a heat pump in their house. Anybody who's got a fridge has got a heat pump. So it's actually a very simple piece of technology. So it's familiarity, I think, with kind of clients, with and end users that becomes the issue. I think there is sometimes a danger of some innovations reaching the market too quickly, before they have been properly tested, before they've been thoroughly evaluated. There was a little bit of this some years ago with small wind, for example, the big kind of market push, and everyone's getting little wind turbines put onto their houses, which wasn't really a particularly kind of good thing to do at that particular point. That's not to say wind and building integrated wind can't be really useful and important things, but where you get into a situation where you're just trying to sell stuff, that's tricky. I think also there are barriers to this, which is that the construction industry in general is quite conservative, doesn't really like innovation, doesn't like research, is quite nervous about the unknown. And likes doing the same thing that it always does, so there is a little bit of inertia in the system. Now, in a sense, that's something that the book has touched on, and the research, certainly the research projects have touched on, which is that one of the reasons for that is that you need to do that research as part of that process in order that you learn from what it is that you're doing.
Do you think also that building clients are averse and that they should also be better informed about innovations, because at the end they make decisions and they decide whether it's a worthwhile risk worthwhile taking?
Well, yes, interesting. I mean, as soon as you introduce the word risk, anybody who is responsible for the delivery of a construction project will get very nervous, and rightly so. I mean, I think it's interesting. I mean, a lot of the clients that we've had dealings with are people like housing associations who have been very interested and very proactive in trying out new ideas. They recognise that something has to happen, and they are generally kind of quite forward thinking, and therefore prepared to explore these different aspects. So I think it can happen. I think one of the things is that with anything new, you need to to have a little bit more time to think about it in terms of what is it you want it to do, is it going to work, what are the things that could go wrong, and how can you mitigate for those issues.
What do you think, how important it is really to also collaborate with further education colleges and to influence development of skills required for installation and maintenance of different new technologies?
This is really important. I mean, it is one aspect of a series of things which are contributing to the performance gap. I mean, they are the design, they are construction, they're installation, they are use, and they are maintenance. But the installation is a really key one. Going back to a point I made earlier, if you've got a great bit of technology, if it's not plugged in right or switched on, then it's not going to be very good. And we see a number of situations where stuff has not been terribly well installed because it's extremely unfamiliar. I mean, anecdotally, I know of people who have been installing systems and they've got the installation instructions, but they don't actually know what they do or what they're for. And they're under pressure to deliver a certain number in a day and so on. So there is a quite important role there in terms of both people understanding how to install systems, but also how they are supposed to work and be used. It's often the case that the person doing an installation is the person that the building user speaks to. So the plumber is going in and has put a piece of kit in and tells the user how it's going to work. So that's a really important role there.
Thank you very much. Where do you see future research or future priorities going? Are there any indications of new areas of research that have to be tackled?
Well, to pick up a point, I think it was David made. Sometimes we don't. We sometimes don't know what we don't know, and there will be areas of new research. There will be certainly areas in terms of particular building technologies which are likely to improve. We know, for example, that photovoltaics will improve in their performance, in their efficiency. And all you need is some kind of breakthrough, and that could be a kind of game changer in those types of things. I think one of the things that is becoming important, and again this was alluded to earlier, is having systems which are robust, which are easy to use, which are easy to maintain. That's a particular problem. Again, particularly in some types of environments, in domestic environments. Something which you have to keep running year after year after year, that maintenance becomes fairly kind of critical.
We have a question here from, I think, researcher at Edinburgh Napier University. How are buildings modeled according to ASHRAE code and keeping in mind thermal comfort, humidity, moisture in the building, and moisture in the building? Could you answer to this one?
Yeah, I mean, there's some interesting things there. I mean, it may be it may be ASHRAE, but it may also be more standards of comfort to do with CIC, for example. One of the interesting observations I have is that there are often differences between expectations between different areas. So, for example, CIC guide for comfort for living rooms say comfort temperatures are between 22 and 23. A SAP model will assume 21 degrees. So you've got these kind of mismatches, which are interesting and need to be addressed. We're certainly seeing that in all the modelling we're involved in, where actual people's comfort temperatures are substantially higher than predicted. So we're seeing houses which never, ever, ever, in the middle of winter, go below 21 degrees. We have bedrooms averaging 23 degrees, 24 degrees. So, incredibly kind of warm. And but when we ask people, are you comfortable in these houses? They're saying, yes, it's fine. They're not saying they're hot. So I think these things are moving targets a little bit. And probably some work needs to be done in terms of what acceptable comfort is looking like these days.
Okay, well, we don't have any more questions from our online viewers. What would you like to say, or maybe we shall say together, about the Kickstart Online project, and any questions that our members or now online viewers also might have in future?
I mean, one observation I have from the programme is that it was extremely good at making contact with SMEs. And it's SMEs who tend to be the more innovative. You know, it's people who are coming up with new ideas, who are trying to do something on the ground. So being able to make contacts with those sorts of organisations and universities and their kind of research departments was actually really kind of very, very valuable. I think the access to the small kind of kickstart funds was extremely helpful. That made it very easy to get those projects up and running and do things kind of quickly and easily. And it supported SMEs who had a research question, and it may only have been a question. It may be something that they wouldn't necessarily have been prepared to invest in heavily themselves. It wasn't something that was close to market, but it was a line of inquiry which they wanted to take. So being able to support that was really very good. I think the other observation about that is that it also then helped us, all the universities, to make links with those organisations which have gone on to do other kind of other projects, sometimes much larger projects subsequent to that. So that was very positive.
I agree also that the project showed that collaboration between universities can be also undertaken very successfully, and that's what led to our current project, Mainstreaming Innovation, probably will lead to continuation of this project. And also what I think was interesting, and for all of us exciting a little bit, to have webinars, to have this type of direct communication with professionals, viewers, anyone interested in this area across Scotland, UK, and in some other countries. So using this technology was really helpful in establishing the contacts and sharing knowledge. At the end, that's what was one of the big aims of our project.
I mean, the other thing about the webinars is, and all those studies, is that they then also provide a legacy. I mean, anybody going onto the website can find that data. It exists in a very kind of public and accessible way. I mean, obviously we have the book as well, but not everybody would necessarily kind of find the book. I mean, the book is very useful for putting something into a kind of particular academic context. But for someone who is just doing a search for something, having that information online and accessible is extremely useful.
Yes. Okay, well, we don't have any more questions, so I would like to thank you now, and also to attract attention of our online viewers forthcoming webinars. And the next one is on 20th of March. The title is Post-Occupancy Evaluation, Justification, Case Studies and Practice, and the Potential for Future Alignment with Government Soft Landings. The speaker is Howard Jeffrey of Skanska. And on 21st of March, we have a webinar on the future for electric storage heating. Speakers are Katalin Svehla and Simon Gill of University of Strathclyde. Please book places online, and thank you very much for watching this webinar. Thank you.
Thank you.